All right, so this video is on lesson 2 to 3, making predictions, observing change, and chemical versus physical change. All right, so a couple definitions to start with. A physical change is when a substance, also known as a compound or a molecule, changes phase or dissolves, aka becomes aqueous. Its formula does not change, right? So it just changes a state of matter. And if you've forgotten, a couple of examples of a compound would be things like H2O, NaCl, salts, etc. It's basically two or more atoms bonded together in a specific ratio, right? We learned this before in Unit 3, so hopefully you still remember that. If you don't, make sure you have this written down. So a couple of examples of just a physical change. So if I have water that starts out at liquid form, H2O, remember L means liquid, and it becomes H2O gas, nothing really happened to the bonds of the atom. It's still H2O, it's still water, it just became from a liquid to a gas. So basically what that means is that in a physical change, if I were to draw this out in the molecular view, for example, I had H2, I would still have two hydrogens, one oxygen, right? H2, two hydrogens, O, no subscript, so just one oxygen. That's my H2O, right? If a physical change did occur, I'd still have oxygen, with hydrogen. It looks exactly the same at the molecular view, right? Nothing happened. Pretty boring. A second example is something that's aqueous. You might notice that I start with one reactant and I end up with two products. So you might think, oh, this must be a chemical change. But remember that aqueous stands for in water. Aqueous equals in water. So that means this NaCl, the sodium chloride, is mixed with water. And in my product side, I have solid NaCl and liquid water. So it's kind of the same thing that's going on. It's just written a little bit differently. Let me draw that out for you. So let's say I have, let's do a different color. Purple, because purple's awesome. Na, sodium, plus chlorine. So NaCl in aqueous means I also have H2O, right? Because it's in water, it's surrounded by water. So these would be my reactants because it's aqueous, and aqueous means in water, right? So if I were to draw out the products, it would be NaCl still, just the only thing that's different is that it's in solid form, chlorine, and water again. So there's still water, there's still NaCl. It's not a chemical change, it's just a physical change specifically for NaCl. Right? So a lot of people got tripped up. I think this was question number 5 on the open notes quiz. So let's move on to chemical change. So chemical change is when a substance or a compound rearranges its atoms to make another substance or compound. So in this case, bonds change. They switch their partners. So when we're talking about rearranges, we're talking about bonds changing. They're switching partners, switching buddies. So for example, I have two Na solids or two sodium solids. This doesn't mean that they're bonded together because it's not a subscript. Because it's a coefficient, which is the number in front, that just means I have two sodiums, not connected together. They're not friends, right? And that's mixed with chlorine, Cl. My subscript is 2, so that means they are bonded together. Just going to draw that. Right, so these are my reactants. I have two NAs, or two sodiums that are separate, and I have Cl2, or chlorines, that are bonded together. If I mix them together, a reaction is going to occur, and I'm going to end up with NaCl, specifically 2 molecules of NaCl, because that's my coefficient. So if I were to draw out what this molecule would look like, it's because I have Na bonded to Cl, and I have 2 of them, remember, so I have another Na bonded with a Cl, or a chlorine. Boom. So in this case, if I'm comparing these two, right, remember this top portion is a physical change. This bottom portion is a chemical change. So notice that whatever its partners were before, so blue was with blue in this case, purple was by itself. Now in a chemical change, my purple is bonded with my blue, or my sodium is bonded with my chlorine. If I look at just a physical change, whatever was before in my reactants, so before purple was with blue, in my products, purple is still with blue, and so on and so forth. So the bonds don't change, they don't switch partners or anything. In a chemical change, they do switch partners. Right? Same thing, this is just another particular example. You can draw out this for yourself just to double check. Right? That's pretty much it for lessons 2 and 3. I'm going to scroll down to your practice problems. So your practice problems are a little bit of review from lesson 1, in addition lesson 2 and 3 as well. So for practice problems, determine whether the chemical equations are a chemical change or a physical change. Then interpret the chemical equations that undergo a chemical change only. So if it's a chemical change, you're going to write an interpretation of it, right? So just a reminder of what that is. So I would have to find the name of CH4O added to oxygen to produce CH2O and H2O. Right? If you still have no idea what I'm talking about, you probably want to rewatch the video of lesson 1, part 2. You don't need to watch part 1 over again, but definitely watch lesson 1, part 2.